Now let's practice finding the domains of any log function. So in these three examples below, they are natural logs, but finding the domain works for any log of any base in the way I'm going to show you in this video. So if you're given a log function, for example, y equals natural log of x, remember that we can always rewrite that log equation in exponential form. For this natural log of base e, it would be e to the y equals x. So we have to think about e, a positive base raised to any power, will always be greater than 0. Therefore, that x value, which is inside of that log, that x must always be greater than 0. We can use that property to find the domain of the functions below, and we're going to go a step further and sketch them as well. So in part A, we have f of x equals natural log of x minus 2. So what's inside of my log now is x minus 2 instead of x. So what's inside of my log, x minus 2 must be greater than 0. So solving for x, that means x must be greater than 2, always. So that tells us that our domain is from 2 to infinity. And we also know, since we don't go below 2, that we have a vertical asymptote at x equals 2. We can also go a step further to find the x-intercept algebraically. Remember, in order to find the x-intercept, we let y equal 0. Well, y is f of x, so I'll have 0 equals ln of x minus 2. I can rewrite this in exponential form. E to the 0 equals x minus 2. Remember, anything to the 0 power is 1. 1 equals x minus 2. So if I add 2 to both sides, x equals 3 is my x-intercept. Now that I know that, I can sketch my graph. First, I know that I have a vertical asymptote here. Oops, wrong spot. First, I see I have a vertical asymptote here at x equals 2. And I know my x-intercept is here at 3, 0. And remember, logarithmic functions always get really close to that vertical asymptote and grow. So this is a way of sketching with my vertical asymptote and my x-intercept. Same idea here in part B. Now what's inside of my log is 2 minus x. So I know that 2 minus x is greater than 0, or 2 is greater than x. I can also write that as x is less than 2. So my domain is from negative infinity to 2. Since 2 is the greatest my x values go, I know I have a vertical asymptote at x equals 2. I can also go a step further and find my x-intercept algebraically. So remember, for my x-intercept, y equals 0. 0 equals ln of 2 minus x. Well, ln is log base e. I can rewrite this in exponential form. E to the 0 equals 2 minus x. So that is 1 equals 2 minus x. I can add x and subtract 1, and I'll get that x equals 1 as my x-intercept. So now if I want to sketch this curve, first thing I'm going to sketch is my vertical asymptote here at x equals 2. And I know I have an x-intercept here at 1, 0. And remember, our log functions get really close to our vertical asymptote, goes through our x-intercept, and keeps growing. I forgot to label this. This is f of x, and this is g of x. So let's get into the same idea here on part C. Now x squared is inside of my log. So I know that x squared must be greater than 0. Well, that's always true as long as x does not equal 0. So my domain is negative infinity to 0 union 0 to infinity. And that means I'm going to have a vertical asymptote at x equals 0. So now let's solve for the x-intercept algebraically. That means y is 0. 0 equals ln of x squared. Ln is log base e, so if I write this in exponential form, e to the 0 equals x squared, or 1 equals x squared. I could square root both sides now, and I'll have x equals positive or negative 1. So now I have two x-intercepts here. So the first thing I'm going to sketch is my vertical asymptote here at x equals 0. And I know I have two x-intercepts, one at 1, 0 and one at negative 1, 0. And so now this log function has two parts of its curve. One going through this x-intercept and the other one going through this x-intercept. Oh, that was not a great sketch. Let me do that again. One going through this x-intercept, and this is h of x. So if you have a function and I ask you just to sketch it quickly, find the domain, find the vertical asymptote, and find the x-intercept by setting y equal to 0. And you can make a quick sketch of any log function of any base.